So one of the revision questions is, ouch, yeah, what is k-means? How can you select k-means? So k-means is a is an algorithm for clustering, and clustering is when you have data points without without labels. Uh, how can you select k for k-means? K is the ideal number of clusters. So how do we select? So there are two approaches to select k-means. Sorry, to select the number of clusters. Uh, k in Okay, fine. Let me just answer the first question. What is k-means? Okay, I said k-means is an algorithm for clustering, and I told what is clustering. Okay, so maybe I should just explain a little bit about the mechanics of the algorithm and how it works, and then move on to answering how can you select k for k-means. Okay, cool. So yeah, so mm, yeah, so in k-means, uh, we select the approach is to select uh, actually k. Okay, uh, there is an optimal. So I can tell you the optimization problem of k-means. Uh, or what can I say? Okay, see, the objective of k-means is to actually say, okay, let me tell you what the problem is. Okay, the problem is we have a whole bunch of data points. By bunch, I mean like, like millions of data points, and we need to group them according to some kind of criteria, and any kind of criteria. Like we don't have any target or any kind of labeling to group them. Okay, this is the problem. So the problem is, uh, one way how to group points together is based on how we decide what a cluster is. So is how we decide what a cluster is. Or a related question, how do we decide that a point belongs to one cluster? So this is the most, okay, so I've been beating around the concepts. So uh, let me introduce the problem once again. What is the clustering problem? The clustering problem is to find points which are in a whole set of data points. The clustering uh, problem, or the objective, is to find points which are similar to each other, which are more similar to or which are similar to each other amongst this whole set of points, data points, right? So how do we cluster that? The directly the question reduces to what is our similarity method? Like how do we decide that two points are similar? So the easiest way, or the most intuitive, or the first thing which comes to our minds is if two points are closer together, then they are similar, rather than say they are farther apart. So this concept of distance for similarity, so measuring similarity using the distance, more specifically the Euclidean distance. Okay, I need not go into the distance, all kinds of difference now. So distance. So when we use distance, our regular Euclidean, or what can I say, our regular distance as a metric for similarity among points, we get the k-means algorithm. Or So now that we have decided okay, let me just, okay, I have come to the metric part is quite clear. So now that I've come to to choosing a metric, a distance metric for similarity among points. Now comes the algorithm part. Okay, the an algorithm which incorporates this metric. So k-means is an algorithm where where we where we assume that they are that there are k clusters, and and we assume that there are we assume that there are k clusters in the data set, and then try and we and we try to find the objective function based on the similarity metric of this distance. So how do we go about that? I think I'll have to use a pen and paper to put it. So let us say we have let's say we have many points. There's a cluster over here, and we have some points like this. So these points are similar to each other. All these are closer by. So k-means assumes uh, so k-means is an algorithm to uh, to minimize or okay. So from the beginning, I've been saying that k-means is an algorithm, but there's a correction over here. K-means is an optimization problem. So first, I need to tell you what I need to formally state the optimization problem in clustering based on similarity metric. K means K means is an assumption, or probably uh, K means is basically an assumption that this is our optima is an assumption on the op is one way to K means is one optimization problem, or basically is one way. Yeah, I mean, I think this is what k-means is. K-means is an optimization problem, and k-means has these considerations. Okay, full correction. K-means is not an algorithm. K-means is an optimization problem. Okay, with its and which has the following considerations, which is with its objective as the objective of this optimization problem is to minimize the Euclidean distance uh, within the cluster, and maximize is to find and maximize the intercluster distance. Maximize this. So let me see what. So to minimize the intra-cluster distance, we could state it as, so let us say this is one point xi, and if we assume one point as the center, So in k-means, uh, the approach is to the approach of of a cluster is to take one point as the center of the cluster. Mm, okay, how, what does k-means consider as a cluster? K-means assumes a circular region with some kind of distance. We call this a centroid. Damn it, I'm throwing words now. Okay, okay. The job is to find the set of points which are close. Cluster is a set of points which are near to the center of the cluster. Awesome. Um, the, okay. So I'm assuming that what I just said is completely rational. I'll just write down the formula. It will make sense. So yeah. So we need to minimize the average intra-cluster distance. So what is intra-cluster distance? So this is, let's say this is one point xi and this is the centroid. Xi minus c square. Okay, and if we want to minimize average, it also means we want to minimize the sum. Okay, so for all points I in this cluster, we want to sum this, and we want to, so this becomes the uh, a proxy for average. The sum total becomes the proxy for the average uh, clustered distance. Cool. Similarly, we want to do this for all the k clusters. I think I am correct. Let me just check. K-means clustering. Let me check the optimization problem. K-means clustering is blah 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 blah. Discussion. Okay. Yeah. Given a set of observations where each observation minimize the within, okay, it's called within cluster sum of squares. Anyways, so this is like the distance between distance from the centroid to the point. And okay, so here it's written for all x belong to Si. I just wrote it as I. So Si is just the set of points which are, Si is a cluster, is that cluster. And argument of S, given a set of observations where each observation is a d-dimensional real vector, K means aims to partition the observations. Okay, instead of repeating the word cluster, partition the n observations into k sets so as to minimize the within cluster sum of squares. Wow, so concise. Anyways, so I'm partly correct. about k-means. I mean, I am correct, but my formulation is like not sound. mm, so what's next? What was the question, by the way? The question was, what is k-means? How can you select k for k-means? So k-means is a scheme or a method to partition observations of the data sets into clusters, and that leads us to what is a cluster. A cluster is a set of points which are near to the to a to a to the center of the cluster. I mean, this is where it bugs me like hell. If I'm trying to define cluster, before the definition, in the definition of the cluster, if I'm referencing the cluster mean, then how the hell am I doing it right? Let me leave this now. How can you select k for k-means? Or you mean the number of... Okay, this is a simpler question to ask. How how to select k for k-means? So what is k? K is basically the number of clusters. K is basically the number of clusters. How to select this? So in other words, the question is, for a given data, uh, or a given problem, what what is a good guess of the number of clusters? So one thing from the lecture video is, if you know about the problem, for example, if you know that the data set is, let us say, uh, it's let us say the the blood groups, okay, not blood groups, or maybe some such similar property. What property? Okay, I mean, I'll come. mm, okay, although we don't have... Okay, let's say it's a set of reviews about movies on Netflix, and let's say we have 10 million reviews of movies, and uh, we want to cluster them, uh, just for the sake of this. I mean, because we would already have the genre and etc. And other characterizations are well captured in the form, so it's not a good real world example, but let's say it's just a challenge, I mean, for the sake of this video. So we have, let's say, 10 million reviews of different movies, without with the genres, and maybe the actors, or the directors, that kind of meta information hidden from us. And now we want to run this algorithm and say our our met say and say our what cluster the kind of clustering we want is to we want to find together the review texts. Can we find together reviews of texts which belong to, say, same directors, one particular director? I mean, is there going to be are the texts about one are the reviews about one particular director going to be, some way clustered? I mean, I mean, so this depends on the problem. Will the reviews of one genre of film, let's say horror movies, or okay, romantic comedies, will all movies be similar? I don't know. Would they be similar if we had 10 million texts? or we could have very simple where kind of clusters, criteria of clusters, where can we where can we group these into clusters based on uh, let's say the sentiment being is do they think the movie is good or do they think the movie is bad? Okay, so so the point I wanted to say is how to select the number of optimal clusters. In case of the genre of the movies, it would be, let's say we have 5 or 10 genres of movies, so we would select 5. Or in case if we want to know whether it's positive or negative, we would select 2. Because we know. So one way to select the k or the number of clusters is based on our knowledge of the problem. If we know this prior hand, then selecting k becomes easy. Another way is, since we have since we our approach is to minimize this loss. Let's say we select k as 5 and we get some loss, say 100, and we select k as 4 and we get it as, sorry, let's say we select k as 6 and we get it as 80. So we could we could choose the k which is giving less value for this loss. This is our loss score. Like we want to minimize this criteria. So the clusters for which this is minimal are good clusters, and we may just select that abstractly. So cool. So I so how can we select k for k-means is equivalent to how many clusters do you think are there in the data, or how many clusters should we tell the algorithm to find, because this is that kind of algorithm where we priorly need it. The algorithm is actually asking us uh, for, you know, is asking us, tell me how many clusters do you want me to find. It's crazy. I mean, we wanted to find the clusters, but the algorithm itself is asking us. So in what way is this helping us? Computationally, yeah. I mean, the computer that does it, that's the helping part. Maybe just some thoughts. Yeah, so one is from domain knowledge and other is, we could say, the computer purely pick the number of those clusters where this criteria is minimal. Any other criteria, do let me know. Cool. And what is k-means, and awesome, let me know if your understanding about it, hopefully in a much concise way. It is like 24 minutes.